Hi everyone, and welcome back to our IGCSE Computer Science lecture series. Today's topic is hexadecimal. We have now worked with binary, which is base 2. Hexadecimal is base 16. It uses 16 different digits instead of just 2. So let's get an idea. Hexadecimal uses digits 0 through 9, which you already know, and then A to F, which represent the values 10 to 15. Now, this might look odd at first. Using letters can be a bit unusual. However, I promise the reason will become clear very shortly. So, why do we actually use hexadecimal in computing? Well, let's start with an example. Well, in here, you have a representation of a memory address in binary. What we see here is that it's long, it's repetitive, and it's very easy to misread. Now look at the right column here. This is the exact same value written in hexadecimal. It's FF0AB2. It's much shorter, it's much easier to write down and check, and the good news is that hexadecimal maps directly onto binary. So you do not lose any information and you're just writing it in a more compact form. Now hexadecimal is used in several places in computing. It's used in memory addresses, where the CPU needs to refer to locations in RAM. It's used in color codes in web design, where a color like, let's say, bright orange is written as hash FF 5733. It's also used in MAC addresses on network hardware. Anytime you see a long sequence of digits and letters like this, for example, it is almost certainly hexadecimal. Now, let me show you how hexadenary works. The method is the same as binary to denary. Each digit gets multiplied by its place value, and then you add the results. For hexadecimal, the place values are powers of 16. The rightmost column is worth 1, and that's 16 to the power of 0. The next column is worth 16. The next one is worth 256, which is 16 to the power of 2, and it goes on. Now, the first example, we have to convert the hex number 2b to denary. The digit 2 here is in the 16th column, so 2 times 16 equals 32. The digit b has the value 11 if we look at it in the map here. So b maps to 11. So what we do is we multiply 11 times 1, which is 11, and then we add these results and we obtain the number 43. So 2b in hex is equal to 43. Let's look at another example. We have the number 4f in hex that we want to convert to denary. 4 times 16 equals 64. And then we have f, which has a value of 15. If we look at it up in the table above, we have 15 times 1 equals 15. And then we add these results, we get 79 as our answer. So 4f in hex is equal to 79 in denary. Now, there are three things that I want you to take away from this video. Hex is base 16. Digits are 0 to 9 and then A to F. A maps to 10, F maps to 15, and the letters in between maps to numbers in between these. Hex is used because it is compact, it's a readable shorthand for binary, and it's very easy and convenient to use throughout in the computing industry. So to convert hex to denary, we multiply each digit by its place value and add, much like the process of converting from binary to denary. Now, in the next video, we go a step further and look at converting directly between hex and binary. That conversion has a very neat trick that makes it faster, much faster than going via denary. So I'll see you there.